what we're going to do today, so this is the first lesson in trigonometry. So what we're going to do today is we're going to revise our grade 11 trigonometry, and our grade 11 trig is vital for matric. It's very, very, very important. So all the things that we learned last year with respect to reduction formulae, cofunctions, how to simplify expressions, our identities, etc., are important for grade 12. All of that work is important. Also, the kinds of questions that we get given in trig don't change. So we have to be able to work with Pythagoras. We have to be able to work with ratio in terms of a letter. We have to be able to prove an identity. We have to be able to solve trig equations and do general solutions. So we do all those same types of questions, but what we do is we include compound angles and double angles. So after we finish the revision of the grade 11 trig, we're going to move on to compound angles and double angles. And then I will start showing you how they then incorporate that new work into these same types of questions that we've been given before. Okay, so that's the sort of general idea. Okay. Oh, let's see. Tandalweto's got good news for us. I have exciting news. My math marks have improved with 35%. I got 70% from. Oh man, that is so brilliant. Well done, Tandalwetu. You go, girl. That is beautiful. Oh, I love hearing news like that. Excellent. Well done. That's really, really great. Well done. So it's not us, it's you. It's you. You wrote the test. You made that happen. So well done to you. That's absolutely brilliant. Good stuff. Okay. Anybody else got any cool news to share? Even if it's something that wasn't great, you wrote a test and it didn't go well. Or can we get started? Always nice to hear good news though, isn't it, Yolanda?
It's always good.
Always good to hear good
we
news. Okay.
brag about you guys like
We
on our
do.
meetings and
Absolutely. Okay, so I'm going to get started since we're already a couple of minutes in. What I've got in front of us here is a set of X and Y axes. So I just want to go through the Cartesian plane because that's a very important basis for all our grade 11 trigonometry. All right, so when we are in this quadrant over here, we call this one quadrant number 1, this one quadrant number 2, this one quadrant number 3. So we use Roman numerals. I don't know why. And this one is quadrant number 4. The other thing that is important to us is that over here, this has been decided that is 0 degrees. So up here, this would be 90 degrees because that makes a right angle. Then here we have a straight line. So that would be 180. It would be 270 degrees over here. And a full circle would take us back to 0. Okay. So in quadrant number 1, our X coordinate is positive and our Y coordinate is positive. In quadrant number 2, our X coordinate is negative and our Y coordinate is positive. Una got 90% for her cycle test on functions, sequences, and series. That is amazing. Well done, Una. Lovely,
guys.
lovely. We love hearing stuff like that. Seriously, wonderful stuff. Faheen, you wanted to ask something quickly before we get started? Go for it.
It's not about work, ma'am. I just wanted to ask, can I still join classes after I finish my rewrite because I'll be done by June with my exams. So can I still join you guys till you finish? Then
I'm sure you can. I'm sure you can. I'm sure you can. We'll double check for you, but I don't see what would be the problem with that. If you wanted to still join the classes, I don't think that would be a problem.
Well,
okay,
but good stimulation for my mind. That's why I thought maybe stay with you guys till we finish at least.
Yes, that's fine. No problem at all. I'll double check, but yeah, I'm sure that won't be a problem at all. Okay. Cool. All right, let's carry on. So anybody know what the signs of X and Y are in quadrant number 3? Both X and Y are in quadrant 3 matrix.
Negative.
Negative, quite right. Okay, so x is negative and y is negative in quadrant 3. And then when we get to quadrant 4, what can we say about x in quadrant 4, Matrix? In quadrant 4, it's positive, quite right. So x is positive and y is negative. So basically the way it works is like this, okay? To the right of the y-axis, as we're all looking at it, x is positive. So x is positive in quadrants 1 and 4. To the left of the y-axis, x is negative. So it's negative in quadrants 2 and 3. Y is positive in quadrants 1 and 2, and y is negative in quadrants 3 and 4. And the reason that this is so important is that when we are working on the Cartesian plane, x and y represent coordinates. So in other words, when we're using the theorem of Pythagoras to calculate a missing value, x and y represent coordinates. Right. Your terminal arm, R, is the one that is anchored at the origin, and it swings about the Cartesian plane in an anti-clockwise manner when angles are positive. So it's lying flat essentially on top of the x-axis, and we create an angle of inclination essentially, all right, that could be 360 degrees or bigger. When we go in the opposite direction, angles are positive. So for example, if I elevate my terminal arm and it comes to rest over here, I could say that I've gone theta degrees in this particular direction. So anti-clockwise is positive. If I take my terminal arm and I go in this direction, then this way angles are negative, right? So this would just be minus theta degrees. Okay, so I elevate my terminal arm and it can come to rest in quadrant number 1, or it could come to rest in quadrant 2 or 3 or 4. At the end over here, this is where my coordinates x and y are located, and r is the length of the terminal arm. Right, so that's very important for us. When we are working in the first quadrant, we would either refer to our angle as theta, or we could refer to it as 90 minus theta. So in other words, we've gone 90 degrees and then theta degrees in the other direction. Okay, so theta and 90 minus theta, well, 90 minus theta would be our reduction formula for quadrant number 1. When we get into quadrant number 2, we would go 90 degrees and then we would go further over to the left-hand side. So that's why we would use 90 plus theta to say that we are in quadrant number 2. The alternative to this, of course, is that we go 180 degrees in an anti-clockwise direction and then theta degrees back towards 0. So because we're going in the opposite direction, we would say minus theta. Okay, so both 90 plus theta and 180 minus theta refer to quadrant 2. The difference, of course, is that when we are working with 90 plus and 90 minus, something happens that doesn't happen when we're working with 180 minus or 180 plus or 180 minus or 360 minus. But we'll talk about that now. When we get into quadrant 3, the only reduction formula that we are going to be using would be 180 plus. And when we're working in the fourth quadrant, the only reduction formula we would use would be 360 minus theta degrees. Okay, before I continue, is that okay? Is everybody happy with what I've said? Are there any questions at this point?
I see some thumbs up coming through.
Okay, are there thumbs up? So we all good? We're happy, we all know this.
Nice, guys.
Lovely. Okay, so let's talk about the 180 minus, 180 plus, 360 minus first, and then we'll come back to 90 plus and 90 minus. Okay, so when we are talking about the sign of 180 minus theta, what we want to do is we want to reduce this angle so that we are writing it in terms of theta. So we would say that the sine of 180 minus theta puts us into the second quadrant where sine theta is positive. So this would reduce to sine theta, for example. All right. If we were talking about the cos of 180 minus theta, and this is because sine theta, sorry, let me just explain that as well. That is because sine theta is defined as y over r. Okay, so opposite over hypotenuse is what we called it when we were in grade 10, but it's y over r. So because y is positive in quadrant 2, that's why it reduces to positive sine theta. Cos 180 minus theta reduces to negative cos theta. This is because cos theta in this quadrant is x is negative. Okay, so because cos theta would give us negative x over r, that's why the cos of 180 minus theta would give us negative cos theta. So it's our ratio that's going to be negative. Okay, and then finally, if we said the tan of 180 minus theta, this would reduce to negative tan theta. And the reason for this is because in the second quadrant, x is negative, but y is positive. So it would be positive y over negative x. All right. Similarly, we have to learn this for all our reduction formulae. So that means that in grade 11, you would have learned sine 180 plus theta. What does that reduce to? Can anybody tell me? What does sine 180 plus theta reduce to? Yes, Morgan.
Negative sine.
Negative sine theta, absolutely. Now that I've got you, what does cos 180 plus theta reduce to?
Negative cos theta.
Absolutely. And then tan 180 plus theta reduces to?
Tan theta.
It does indeed. Okay, very nicely said. Thank you so much. Okay, and again, it's because both x and y are negative in quadrant number 3, and negative divided by negative would give us a positive. That's why tan theta is positive. Okay, so somebody else who's feeling brave, let's just do sine 360 minus theta. What does that reduce to? Anybody else willing to talk?
Hello, ma'am.
Yes. Hello, Omokolo. Go for it.
The answer will be negative sine.
Okay,
Theta.
negative sine theta. All right, and that's because y is negative. Go for it. So now as far as, oopsie, that's not what I meant to write. So now cos 360 minus theta, what does that reduce to?
Cos theta.
Uh-huh. And tan 360 minus theta?
Minus tan theta.
Minus tan theta. Absolutely. Okay, so you all know those really well, and that's brilliant. That's the basis of what it is that we are going to be doing. So we need to know those 100%. Okay, let's talk about 90 plus and 90 minus. Okay, when it comes to 90 minus theta, all right, we learn two things. So we learn the cos of 90 minus theta, and we learn the sine of 90 minus theta. Okay, so the cos of 90 minus theta, now somebody else, I know, I think it was, somebody put their hand up earlier. Let's just go back and have a look. Oh no, it's gone now.
The cos of that.
Okay, Omokholo, that's fine. So the cos of 90 minus theta becomes?
Sine theta.
Sine theta. Okay, and the sine of 90 minus theta, Omokholo, becomes?
Cos theta.
It certainly does. Okay, so now somebody else, not Omokholo or Morgan or anyone else, somebody different. What happens with 90 plus? What happens with the sine of 90 plus theta? What does that reduce to? Zintle, yes, go for it.
Thank you, Zintle.
Yes.
Then does it not change to negative sine theta?
It doesn't. It doesn't. It changes to positive cos theta. Okay, but we're going to talk about now. We're going to talk about it just now if you don't understand why. Okay. Zintle, do you know what happens to cos 90 plus theta?
No, ma'am.
Okay, that's fine. That's why I'm glad I'm revising all of this. Now, I see somebody else has put their hand up. Sibongenhle, go for it. Do you know what happens to cos 90 plus theta?
Ma'am, it would become negative cos theta. Negative sine theta.
Negative sine theta. Quite right. Absolutely. So it would become negative sine theta. Okay, brilliant. Okay. Absolutely. Why does this happen? Okay, so the reason, okay, you were expected to learn these first of all. Okay, so you need to know all of this. Otherwise, when they ask you to do questions where you have to simplify, you're not going to get them correct. Okay, very important. I also just want to point out to you, okay, that your ratio will take the sign of the function in that, of the original function in that quadrant. So what I'm saying is this: sine 90 plus theta. 90 plus theta is quadrant 2, and the sine function is positive in quadrant 2. That's why we get positive cos theta as an answer. Similarly, 90 plus theta is negative in quadrant number 2. So when we have the cos of 90 plus theta, cos is going to be negative in quadrant 2. So that's why our answer, our ratio, becomes negative sine theta. That explains the signs. It doesn't explain why sine 90 plus becomes cos theta, and it doesn't explain why cos 90 plus becomes theta, but I am prepared to help you with that. What I just want to point out before we get into these, all right, is that what we've just been doing here, this is what gives rise to our cast diagram. Okay, so because cos is the only function that is positive in quadrant 4, that's why we call this quadrant C. Here, the A stands for all. Here, the S is for sine theta, which is the only trig function that is positive in quadrant 2. And here, tan theta is positive. Okay, so this is where our cast diagram comes from. All right, let's just see if there were a couple of questions before I carry on. Timberletu, did you have a question or did you want to ask? Yes, Tundlewetu, that's right.
You'll have to unmute Timberletu.
Timberletu, you're welcome to unmute and speak. Okay, maybe Timberletu, we can come back to you. Sibongenhle, do you want to ask something?
Yes, ma'am. Ma'am, I
Go
want
for
to
it.
ask if, may you please explain it when it's like sine and then in brackets negative theta and etc.
Yes, absolutely. I'll explain that one as well. I'll tell you what, let me do that before and then I'll go on to the others, because that's also a seen as a reduction formula, essentially. Okay, let's just move down and I'll explain that one and then I can come back to the others. All right, so when we are talking about sine minus theta like that, essentially, Sibongenhle, what's happening here is that minus theta means that you have moved theta degrees from 0 in the opposite direction. So it's this that I was talking about earlier. So essentially, provided that theta is no bigger, so smaller than negative 90, you will end up still being in quadrant number 4, because essentially this is seen as 360. So here, 270 is seen as negative 90. Does that make sense to you? Because it's the same thing. So 360 minus 90 is 270. Okay, so provided that this is not something like sine minus, let's just pick another value, hang on. If this was 120, okay, then I wouldn't be in quadrant 4, I would be in quadrant 3, okay? But this is defined in terms of an acute angle. Right, so what the understanding is that if we've got sine minus theta, we are working in quadrant 4. That's why this would reduce to negative sine theta. cos minus theta, so the minus theta means the same thing. It means we're working in quadrant 4. So this reduces to negative cos theta, sorry, positive cos theta. And tan negative theta, again, it's regarded as working in quadrant 4. So this reduces to negative tan theta. Okay, does that make sense? Sibongenhle, are you happy? Is that making sense? Okay, all right, good. How is everybody else feeling? 100%. Faheen's happy. Good.
Just remember to mute when you're not talking to us.
Okay, Tandalwetu's happy. Tando's happy. Good. All right, so now let's go back to 90 plus and 90 minus. Okay, Sharon, when we are talking about minus theta, so here and here and here, it's like our terminal arm has gone in the opposite direction. So here in the beginning, I drew this pink line in quadrant 1, and I said that the terminal arm had moved 30 degrees in an anti-clockwise direction. Right? If I do a reflection of my terminal arm over the x-axis, it's the same as me moving theta degrees in the opposite direction. So in maths, plus and minus is used for direction. So plus means I'm going in an anti-clockwise direction because angles are getting bigger. I went from 0 to 90, which I rubbed out earlier, to 180 to 270 to 360. If I'm going in the opposite direction, then angles are getting smaller. Okay, so from 360 down to 270, down to 180, back to 90. Okay, so that's why this reflection of this line, it would be seen as I have gone minus theta degrees in the opposite direction. So we understand sine minus theta, cos minus theta, and tan minus theta to mean that the terminal arm has come to rest in the 4th quadrant. So using our cos diagram, that is why sine minus theta is minus sine theta. That's why tan minus theta is minus tan theta, and why cos minus theta is positive cos theta, because we're working in the 4th quadrant. Okay, that's the idea. All right. Okay, let's go back to the 90 minus and the 90 plus. So the best way for me to describe what's happening with 90 minus is to use a right-angled triangle. Okay, so this is supposed to be a right-angled triangle. That's my 90 degrees over here. If this angle over here is theta, how big is this angle over here in terms of theta? Can anybody tell me?
Ma'am, they're equal.
Yes, they're not equal, Lisa. They're not equal because we don't know
Ma'am,
that A and B are equal.
ma'am, can I speak?
Yes, go for it.
Is 90 plus theta?
90 minus theta. 90 minus theta. Okay, so the reason for that, okay, let's call this angle over here, let's call it X. Okay, so the idea is if I add X and 90 and theta together, I'm going to end up with 180 degrees because of the angles of a triangle, right? So if I'm going to make X the subject of the formula, I'm going to take the 90 and the theta over to the other side. So I'd end up with 180 minus 90 minus theta. So that's why it ends up being, sorry, beg your pardon, I wrote the wrong thing, why it ends up being 90 minus theta. Okay, is everybody happy with that? Okay, so that angle is 90 minus theta. Okay, if I, yes, there we go, there we go. Okay, so a lot of you are putting that in the chat. That's really nice. Okay, so it comes from this, okay? If I go back to grade, so we're thinking now in terms of grade 10, right? If I write sine theta, okay, can anybody tell me in terms of A, B, and C, we're not going to use all 3 letters, what is sine theta in this diagram? So in terms of, I've labeled this side over here A, That one over there, B, and the hypotenuse is C. So what is sine theta in terms of A or B or C?
A
Can
over
anybody?
C.
A over C. Okay, so opposite over hypotenuse. Faheen, I see you wanted to ask something or say something. Do you want to go for it?
No, ma'am, I wanted to answer. That's all.
Go for it. It's okay. Do you want to do the next one?
I'll try.
Okay, go for it. Okay, so now I'm asking you for the ratio of cos 90 minus theta. So your angle over here, 90 minus theta, is your reference angle. Okay, what would be what would cos theta be in terms of A or B or C?
Wait, ma'am, can you just repeat that again? I know what you're saying. Can you just please repeat that again?
Absolutely. So the cos of 90 minus theta is equal to what in terms of the diagram that I have given you? So in terms of which sides am I comparing with one another? What's my ratio?
Ma'am, I think I'll give it by B over C. I think.
Okay, but it's cos 90 minus. So when we're talking about the cos of an angle, it is adjacent over hypotenuse. So the side that is adjacent to the angle 90 minus theta is A. Okay, the hypotenuse is C. So this would also be A over C. So in maths, we say that if two things are equal to one another, or sorry, are equal to the same thing, then we can deduce that they must be equal to one another. So that's why sine theta is equal to the cos of 90 minus theta. Okay, so it comes from a right angled triangle. Okay. Now, I see a lot of you are saying, so Latani, Vukudo, Sharon, Alwetu, you're all saying B over C. So in terms of this diagram, B over C would be sine 90 minus theta. B over C would be sine 90 minus theta, or it would be cos theta. Does that make sense to you before I continue? Okay, so sine 90 minus theta would be opposite, which would be B over C. Cos theta, I'm changing my reference angle, then I'm using this as my reference angle. That would be adjacent over hypotenuse. That would be B over C. So that's why the sine of 90 minus theta is cos theta. Yes, we're using SOHCAHTOA. Quite right. Quite right. Okay, so Zoom user, what are you not understanding?
You can
Sorry, I don't
unmute
know
and
your name.
ask. Yeah, you can unmute and ask. You're welcome to ask so Teacher Lee can explain. Yeah.
Yeah, absolutely. Yes, no. All right, I think we've seemed to have lost Zoom user, but please, if you do want to ask again later, you're very welcome.
Hi, ma'am. Sorry, I don't understand why B is not the adjacent side instead of A.
That's fine. Okay, so what we are doing here is that we are changing the reference angle that we are using. I think it's good that you're asking this question because there's probably a lot of people that don't understand, okay? So in terms of, let's just do this one again here, okay? If I am talking about the sine of 90 minus theta, then the angle 90 minus theta is my reference angle. So in relation to where this angle is, the opposite side is B and the hypotenuse is C. Does that make sense? When I'm talking about cos theta, I'm not using 90 minus theta as my reference angle. I'm using theta over here as my reference angle. So cos theta is adjacent, so that would be B over hypotenuse would be C. Okay, so 90 minus theta and theta are two different angles. Both can be used as a reference angle inside your triangle. Okay, because remember, sine theta, cos theta, tan theta only exists in relation to an angle. Okay, so that's why we can never just talk about sine, cos, and tan, because on their own, those words have absolutely no meaning at all. It's only in relation to a specific angle. Okay, so in other words, let me just go and draw something else here for you guys and see if this just also helps to just make a bit more sense. Let's say I decided I wasn't going to call my angle 90 minus theta. So let's call that angle alpha. That's still 90, and let's call this angle theta. All right, and what we can do is we can pretend that we've got a 3, 4, 5 triangle, because we know that that's Pythagoras. If I ask you for the cos of theta, then I'm saying use theta as my reference angle. So how big is the side, or how long is the side opposite theta? Morgan?
4. 4.
It's 4, okay? The side adjacent to theta is?
3.
Beautiful. The hypotenuse is?
5.
Awesome, okay? So cos theta means adjacent over hypotenuse. So in this triangle, it would end up being what over what?
3 over 5.
That's it, Busani, quite right. It would end up being 3 over 5. Okay, now let me change my reference. Okay, let me now use alpha as my reference angle. So now I'm going to write sine alpha. Okay, sine alpha. So in relation to angle alpha, the side opposite it is how long, Matrix? 3. Good. Yes, it's 3. The side adjacent to alpha is 4. Okay, the length of the side of the hypotenuse is still 5. So sine alpha would also end up being 3 over 5. Okay, so it's very, very important. These words do not exist without relation to a specific angle. Okay, does that feel a little bit better? Are we happy? Thumbs up, thumbs down? How are we feeling? Good. Lovely. Okay, so I think for you guys, it's very important that you understand all of this. I don't know what you're like, but I know certainly for me, I cannot learn something off by heart that I do not understand. I need to understand it if I'm going to remember it and be able to use it. So that's why I think it's very important that we discuss all of these things before we actually start using it anywhere. Okay, so yeah, lots of hands ups there. That's great. So make sure you learn your reduction formulae. None of these are given to you and they will expect you to use them. Before we actually go on and do the next question, there's just one other thing that I want to point out to you that also tends to come up every now and again as well. And that's if our ratios have been squared. So what I'm referring to is something like this. Okay, if they ask us to work with, let's say, sine squared 180 plus theta. Okay, what they are doing is that they are squaring the ratio. So in other words, when we now end up working with this, we have to show what we get when we reduce. So we say to ourselves, what is the sine of 180 plus theta? It ends up being negative sine theta. And then that ratio is what is going to be squared. You have to show that step. Okay, otherwise you're going to be penalized for it. And then you can proceed to something like this, sine squared theta. Okay, but this step in the middle is very, very important. Okay, you must show that in trig. Okay, the same thing would happen if you were working with something like this. So tan squared 360 minus theta. Okay, we're working in quadrant 4 where tan theta is negative. So we must write that as follows. and then we're going to square it, and we can end up with tan squared theta. Your alternative to this line that I have highlighted in pink, of course, is to write it out in full. Okay, but that's going to take you a little bit longer. So for example, if I just go back to my tan squared 360 minus theta, the other thing that you are allowed to do is this. You can write this as negative tan theta times, dot means times, negative tan theta. That's also okay. All right, you're still going to end up with positive tan squared theta as your answer. Fusani, you got a question? You're welcome to unmute and ask.
I've been meaning to ask about that square root. So let's say if you are faced with the square root, are you saying that we are supposed to exclude it into including the brackets, and after then it's going to be other than until we know that we find tan squared 360 minus theta on the fourth quadrant.
Yes,
And
absolutely.
then
Yes.
so knowing that it is squared, ne? So why are we changing it to a positive? Because that's where on the fourth quadrant until we find cos positive. So I'm a little bit confused there.
Okay, that's fine. So are you talking about this one here, or are you talking about this one here, or this one, or this one? Which ones are you referring to?
The one you just did, whereby you see that tan squared.
Oh, so the tan
360
squared
minus
360. Okay, that's fine. So the one in green. All right, not a problem. Okay, so now you're quite right. When we look at the cast diagram, we interpret tan 360 minus theta as negative tan theta. But when we square anything in maths, what we are doing is that we are multiplying that thing by itself. All right. So in other words, we are taking the ratio negative tan theta and we are squaring it, which means we're timesing it by ourselves. So what I have written in green over here that I'm sort of highlighting now, what I have written in green over here, it means exactly the same thing as what I've written over there. Okay, so the reason it ends up being positive is because when you multiply a negative value with another negative value, you're going to end up with a positive value. Okay, so
yeah,
that's why it ends up being positive tan squared theta, because when we take anything in maths and we square it, it doesn't matter what our value is, when we square it, it has to be greater than or equal to 0. Okay, so anything squared is going to be greater than or equal to 0. Does that make sense?
Thank you. Now it makes sense. I was
No
a little
problem.
bit confused, but now I
No,
get it.
no, absolutely. It's just because it's been squared. That's why it ends up being positive. Okay. All right. Let's just have a look at the chat, everybody. So the way we got tan squared, is it multiplying tan? Yes, so it's by multiplying negative tan theta with negative tan theta. That's quite right, Tegedi. Okay, and that's what gives us tan squared theta. So we're squaring the ratio, we're not squaring the angle. Okay, so when I talk about a ratio, let me just go back up here. Okay, so A over C is a ratio. Over here, 3/5 is a ratio. All right, so if I'm talking about squaring my ratio, if I say to you, what is the value? Let's talk about this diagram over here. If I say to you guys, what is the value of cos squared alpha? All right, what you're doing is that you're working out the value of cos alpha. So again, alpha is our reference angle. The cos of any angle means adjacent over hypotenuse. So that would be 4/5, and then they want us to square it. Okay, so in that case, it would end up being 16/25. Does that make sense to everybody? So it's the ratio that's squared, not the angle. Okay, how are we feeling now, Matrix? Are we feeling good? Thumbs up, thumbs down. How's everybody feeling? Good. Oh, nice. Lovely. Okay. Oh, lovely. Good. Good, Olwethu. I'm so glad. 2 thumbs ups. Good, good, good. Okay. So let's go and have a look at some other basic information, things that we need to know before we get started on the matric work later this week. Okay. So this is a question on Pythagoras. Okay. And I'm revising this with you because eventually we're going to do Pythagoras and then we're going to include compound and double angles when we do that. So it's important for us to be able to work with these types of questions. Okay, so this question says if tan beta is 2 root 6 over 5 and beta is an angle between 90 and 270, calculate without the use of a calculator and with the aid of a diagram the value of tan beta and then sine 90 plus beta. In these sorts of questions, irrespective of whether they tell you that you're allowed to use a diagram or not, you should always use a diagram. In Trig, we never ever touch our calculators until we are solving for theta and doing trig equations and or general solutions. All right, so all Trig, compound angles, double angles, Pythagoras, ratio in terms of a letter, our identities is all done without the use of a calculator. Are we allowed to use a calculator to work out, for example, if you had to use your calculator to work out 4 over 5 squared is 16 over 25, that doesn't matter. All right, as long as you show your steps, nobody's going to have a problem with that. When they say you're not allowed to use your calculator, what they're really getting at is that you are not supposed to be calculating the size of the angle. So in this sort of question, the one that's on the board at the moment, the size of beta is irrelevant. Okay, we are not calculating the size of beta. And if you do that in tests or exams, then the person marking your work will regard you doing that as you don't understand what the question means and you don't know what you're doing and not going to get any marks. Okay, so we are not calculating tan beta. Tan beta is a ratio. Sine 90 plus beta is a ratio. Okay, so they want ratios from us. They don't want angles. First things first. We look at sine beta and we see that it is positive. It's 2 root 6 over 5. So this is a positive value. We know that sine beta is positive in 2 quadrants. It's either positive in quadrant 1 or it's positive in quadrant number 2. So our terminal arm has to come to rest somewhere. It can't be in quadrant number 1 and in quadrant number 2 at the same time. So it's either one of the two. So we need to go and have a look at the restriction that they have given us on beta to tell us where we are working. Okay, so because our ratio is positive, we could be in quadrant 1 or we could be in quadrant 2. Because they've told us that beta is between 90 and 270, well, we all know that 90 is up here, we know 180 is over there, and we know that 270 is over here. So either that means that we are in quadrant 2 or we are in quadrant 3, right? Because we've got 2 ticks over here, that means we have to be working in quadrant number 2 for this particular question. Okay, so it's these two things together. It's the sign of your ratio together with the restriction that helps you determine which quadrant you are working in. Okay, so we've ascertained it has to be quadrant number 2. So now draw ourselves a proper diagram. There's our set and x of y axes. Our terminal arm has come to rest over here. We are supposed to put in our angle. So there's our angle beta over there. And now let's scrutinize more carefully the information they've given us. We interpret sine beta as y over r. So they are basically telling you that over here, the x coordinate is unknown to us. The y coordinate is 2 root 6, and the length of the terminal arm is 5 units. That's why we call these questions Pythagoras, because we now need to use the theorem of Pythagoras to work out the length, work out the size of x. Sorry. Okay, so Theorem of Pythagoras, x squared plus y squared equals r squared. So we come along and we say x squared plus y squared equals r squared. Okay, so now I'm going to stop there, right? And I'm going to give you guys a chance, because I'm sure all of you have seen this before. I want you to work out the value of x for me, and either you can unmute and tell me what you think it is, or you can pop it into the chat. Please work out the size of x.
Let's go. I see Balulekile is busy, busy, busy. I see you, girl. Let's go. Yeah, so fast.
Some of them are very fast, hey?
Yeah.
Okay, so a lot of people are saying 1. So I'm going to work slowly behind you guys. And this would end up being 25. And that would be 24. And then we would end up with x squared being equal to 1. Okay, let's just see what everybody's saying. Okay. All right. Now, all of you are on the right track, except Omokholo. Omokholo has got -1, and the rest of you all have 1 as an answer. So now I want to ask a question. Omokholo, why are you saying -1 when everyone else is saying 1? Are they
Okay,
right
ma'am.
or are you right?
Ma'am, can we go to the diagram, which the one that you were explaining? I want to show you something there.
This one over here.
Yeah, the diagram. At that diagram, let me see first. Do you see where 102? Where did you write 102 there? And there's
Yeah.
negative x and positive y.
Mm-hmm.
Yeah. So the answer of a negative of that -1, I saw on that statement, that one.
Yes,
That's why I said it's -1.
you are quite right. Absolutely. Okay, absolutely. You are quite right. Okay, and this is where Trig gets us, Matrix.
Have
Is it
fun,
so
girl.
often? I know, and she was the only one that said -1. Very, very nice. So what you can do to remind yourself, Matrix, is do this. When you take a square root, answer could be positive or negative. So I think that this line over here really helps us to jog our memories. Okay, and because we are working in quadrant 2, like Omokholo said, x would have to be -1 and not +1. Okay, so what would end up happening there is that if you said +1, you would get that wrong and you would just get consistent accuracy marks. You wouldn't get all the accuracy marks. Okay, so very, very important, guys. Bear in mind, like Omokholo said, bear in mind your cast diagram. Okay, that's why you've drawn your diagram over here. You're working in quadrant 2. You have to be careful that x and y are coordinates. They change sign depending which quadrant we are working in. R is always positive. R is the length of the terminal arm. Okay, it's the length of the hypotenuse if we were to draw a right angle triangle. Okay, so in other words, if I just extended that a little bit and I brought that down, there would be my right angle triangle. Okay, so R is always positive, but X and Y change sign depending which quadrant we are in. So now when we go and answer our question tan beta, We don't have to do any reduction. Okay, tan beta is already reduced. What they want from us is y over x. That's what tan beta means. So we can see that y is 2 root 6 over -1. Okay, so we would simply write our answer as -2 root 6 as follows. Okay, does that make sense to everybody else? Are we good with that? Thumbs up, thumbs down. Are we happy? Yes. Okay, good, good, good. Okay, so be very careful of your signs. Okay, they love to do that. They love to make you calculate either the x or the y more often than the r, and it's because x and y can change signs. Okay, so be on the lookout for that. Don't fall into the trap. Okay, as far as the next question is concerned, sine 90 plus beta. Okay, so again, this is one of our reduction formulae that we were talking about earlier. Sine 90 plus beta reduces to, and again, they ask this on purpose because they first want to check that we know what it reduces to. Okay, so 90 plus beta is quadrant 2. So sine 90 plus beta reduces to, can anybody remember what that was? What it reduces to?
Sin beta.
Sin beta. Okay, it reduces to cos beta. Okay, so 90 plus and 90 minus mean that sine becomes cos and cos becomes sine. Okay, so don't worry, Morgan, it will come right eventually. Okay, so 90 plus sine 90 plus theta, sorry, becomes cos theta, and cos 90 plus theta becomes negative sine theta. Okay, so this first reduces to positive cos beta. All right, and now we can go ahead and we can go and sub in. Okay, so remember, we interpret cos beta as x over r. Okay, so this will end up being -1 over 5. Okay, quite right. Okay, does that make sense to everybody? Question B.
Yeah.
Okay, Mbalente, I see you saying, please explain further. I'm not sure which one that was. Omogolo, yes, would you have a question?
Ma'am, do you see when you draw a diagram and then
Mhm.
you put beta outside that arrow? So
Yes.
if I read beta inside the triangle, will I be wrong? Will I be penalized in the exam room?
No, you won't be penalized in the exam. But the thing is that beta is not the angle between the x-axis and this line over here. This is not beta. So what I'm coloring in here in red, that's not beta. Beta is your angle of inclination. Okay, so it's this angle over here that I'm going in yellow. That's beta.
Oh,
Okay, that's beta. It's your angle of inclination of your terminal arm. Okay, that's what beta is.
okay, ma'am, can I ask you again? In the
Mm.
instruction, they said you should calculate without using a diagram. Example, let's say they say you should calculate that thing without using a diagram. So
Mm.
I was thinking, I was asking if I draw a diagram in the
Uh-huh.
answer book, and they said I should draw without a diagram, with an aid of a diagram, then I draw that diagram. Will I be penalized at the exam room?
No. You must draw the diagram. They'll never tell you to do it without a diagram. So yeah, you must always draw a diagram even in this question. Even if they don't say so, then you must always draw a diagram. Okay, sometimes under some conditions we get given a mark for the diagram, sometimes we don't. It just depends on the person who set it and whether they actually decide to award a mark or not. Okay, but if you draw the diagram and you've been thorough, then nobody can penalize you. Okay, normally the mark is either on the diagram or on the identity.
Oh,
But yeah, I would just include all of that. Okay.
yes, ma'am.
All right, that's fine. And then, so the part colored pink is our reference angle. No, No, the part colored pink is not our reference angle. All right. Oh, I see what you mean when we are talking when we're working in a right angle triangle. If we were working in the first quadrant, then yes. Okay, but the part colored in pink is 180 minus beta. Okay, that's what the pink part is. Okay, so this pink bit over here, that's 180 minus beta. Because remember, beta and the pink bit add up to 180 degrees. Okay, so in this situation here, we're talking about a terminal arm turning around your Cartesian plane like the minute hand or the hour hand of like a clock, essentially. Okay, so however many degrees it's been swung, that is essentially our reference angle or our angle of inclination. Okay, it can be reduced and written in terms of an angle in the first quadrant, but that angle itself can either be acute or obtuse. It can be greater than 360. If we go in the opposite direction, it can be negative, etc., etc. Okay.